Okay, first homework problem. I'm going to do 6th edition homework problems. For the 7th edition it will be the same problems, just with different values in them. Okay, so this is 32 of the 6th edition or 36 of the 7th edition. Okay, so let's quickly read the question. The texts are too small to put the textbook here, so I'll just read it. I'm told there's a 9500 picofarad capacitor, holds plus and minus charges of 16.5 times 10 to the minus 8 coulombs. What is the voltage across the capacitor? Okay, so this is just a straight Q equal to CV situation. Q equal to CV. The voltage is asked for, the charge and the capacitance is given. So the voltage is the charge on the capacitor over the capacitance, and the charge is given as 16.5 times 10 to the minus 8 coulombs over 9500 times 10 to the minus 9, because it's pico. No, that would be nano. No, pico would be minus 12, isn't it? Yeah, minus okay, no, that's a mess, don't have space. Let's do it neatly over. 9500 times 10 to the minus 12 farad. Okay, farad. And let's calculate that. 16.5 divided by 9500 equals times 10 to the power 4 is equal to that much. How many significant figures I'm going to give? I think 3. So let's say 17.3, and what's it? It is volts. Okay, so that is for question 32. Okay. Next one is 34. So this is 37 in chapter in edition 7. How much charge flows from each terminal of a 12-volt battery when it is connected to a 7 microfarad capacitor? How much charge flows from each terminal of a 12-volt battery when it's connected to... Okay, so what do we have here? We've got our battery. And a switch that has been flipped probably. And there's our capacitor. And this is... Oh, we don't know what the voltage... Oh no, they give it. Yeah, oh yeah, sure. That's 12 volts here, and when the switch is flipped, then charge flows. So this is the positive part, that's the negative part, and then it charge flows until the potential difference here is also 12 volts. Okay, no charges move across the plates. A certain amount of charge moves from here to here towards the battery terminal. And always these are terminals, the plus and minus terminals. So charge moves away from that from the plate here. Negative charge, electrons move away, making it positive, and electrons flow towards this plate, making it negative. And the amount in each case is Q, the charge of the capacitor. Okay. So I just have to find the charge of it. Given the capacitance, that is the 7 microfarad, so it's 7.00 times 10 to the minus 6 farad times the voltage, which is 12.0 volts. So I'm going to give my answer to 3 significant figures. So that is 7 times 10 to the minus 6 times 12, and that is, okay, so I'm going to say it's 8.40 times 10 to the minus 5 coulombs. Okay, next question. 36 or 39 on in the 7th edition. So 36 asks what? Oh, that one's a little bit longer. It says that there's a charge on a capacitor increases by 18 microcoulombs when the voltage across it increases from 97 volts to 121 volts. What is the capacitance of the capacitor? Okay, so it's again asking for the capacitance and information given about the charge and the voltage. So again, I'm going to start with Q equal to CV. And what do they tell me? They tell me that Q, the first it is at 97 volts. So let's say that's equation 1. And then when you increase it to 121 volts, which would be an increase of what? Of 24 volts, then the charge increases by 18 microcoulombs. Is that right? Yes, by 18 microcoulombs. Okay, so that's equation 2. And now we substitute 1 into 2, and then what do we get? So there's Q equal to that much. I plug that in there, so then I get that C times 97 volts plus 18 microcoulombs is equal to C times 121 volts. Okay. Kind of preferable to not use units when you're doing algebraic manipulations like this, but we'll keep track of it. So let's get C by itself. So in other words, C is I'll skip this. I'll skip this step because I know now I subtract this term from that term. So then it's 121 volts minus 97. That is going to be 24 volts. So then I give C is going to be 18 microcoulombs divided by 24 volts. Okay, and now let's calculate that. 18 divided by 24. Good. How many significant figures am I going to provide here? Yeah, 2 probably. Yeah, okay. So 7.5 times 10 to the minus 7, and what's its capacitance? So it is farads. Okay.